All right, here we go. Solving number 2. It says at a certain temperature, the fusion rate of helium is 0.21 meters per second. What is the rate of hydrogen gas under the same conditions? All right, here we go. So we're comparing helium to hydrogen gas. So we always use Graham's law. All right, then we said, remember, number 2, the mass of 2 is always the heavier one. So helium is heavier than hydrogen. Hydrogen is H2, right, because it's diatomic. Helium's mass is 4.00 grams. If the molar mass, if I look on the periodic table, it's 4.00, where hydrogen is 2.02. All right. So I'm going to plug this in. So V1 over V2 equals, and then M2 is 4.00 over 2.02. So this will equal, you got to do it, so 4 divided by 2.02, take the square root of that. So I get V1 over V2 equals 1.4, let me do that better. So 1.41 is what I get, all right? All right, but the second part, it says the fusion rate of helium, right, is 0.21. So I'll rewrite it, V1 over V2 equals 1.41. But what I now figured out is this guy here, that rate, number 2, the fusion rate, or the velocity, is 0.21. So V1 over, this is for helium, V2 is 0.21 equals 1.41. So I actually know one of the variables. And so now I have to figure out the rate of hydrogen gas, which is V1. And so there's multiple ways to solve in this. I think the easiest way to solve this mathematically is to use proportions. So 0.21 equals, and then 1.41 is also 1.41 over 1. So I can cross multiply. So on one side I'll have V1 times 1 equals, and then 1.41. So I do this cross multiplication times 0.21. So if I do that, V1 equals 1.41 times 0.21. So V1 is 0.2, I'll go to 2 sig figs. So it's 0.296, which rounds to 0.30 meters per second. So I just figured out if the helium goes 0.21, then hydrogen will be 0.30. Okay? So in this case, you actually knew three of your variables. You knew V2, you knew M1 and M2, and what you're solving for is the velocity of one, which is the velocity of hydrogen gas.